This next example is given with the same directions as above, so we're asked to find the critical points and identify them as relative max, min, or a saddle point. So we want to take the partial derivative of f with respect to x. We are going to get 12x squared plus 40x minus 4xy. Remember that y is considered to be a constant. Next, the partial with respect to y is where we treat x as a constant. We end up getting 2y minus 2x squared. We are going to continue with derivatives. We're going to find the second partial of f with respect to x again. We're going to get 12x plus 40 minus 4y. The second partial of f, we'll go this way. The second partial of f with respect to x and then y, this is a mixed partial, is going to be, let's see, y is the variable, so that's just going to give you negative 4x. And then the last second partial derivative with respect to y both times will be 2. And that should be it. Next, we are going to find the critical points. Find the critical points. In order to do that, we're going to make a system of equations out of the first two equations you see up there that we computed. Those are the first partial derivatives. And we're going to set each of them equal to 0. We're going to solve these simultaneously. Now, these are not linear, so we can't use matrices. We are going to use a form of substitution. Now, it takes a little bit of a practice to understand which equation to work with and then which variable to solve for. So don't be afraid to try something and then cross it out and try something new if your method that you choose first is not working for you. I'm going to take the second equation because it looks simpler to me, and that's why I'm choosing it. And I'm going to simplify it a little bit more. I can divide everything by a 2. That's going to give me y minus x squared equals 0. And then maybe just take the x squared to the other side. You get y equals x squared. Now the y equals x squared is useful because I can go over into my top equation and replace the variable y with the quantity x squared. So now you will end up getting 12x squared plus 40x minus 4x times x squared equals 0. This is the equation that we now need to solve for x, which is the remaining variable, the last remaining variable. All right, so I'm going to rearrange it a little bit. I'm going to divide out by the common factor of 4. And when I do this, I'm going to end up getting x cubed minus 10x minus, you know what, put the, sorry about that. Let's put x cubed minus 3x squared minus 10x. Put them in that order. So once again, I took everything to the right-hand side, I divided it out by the common factor of 4, and this is what I get as a result. So take a couple minutes if you need to make sure you understand where this comes from. It's just basic algebra techniques. Next, you want to factor, right? We're solving for x. Typically, that means factor. Let's bring out that common factor of x and see what we have from there. And then I noticed that the remaining quantity in parentheses is just a quadratic expression, and I can factor that pretty easily here into x minus 5x plus 2. So I get 3 solutions for x. I get x equals 0, x equals 5, and x equals negative 2, right? From setting each of these 3 factors equal to 0. Next, you have to find the y values that correspond to these 3 values of x, and we're going to do that by going back to this equation right here. Honestly, any of the equations that you have that relate just x and y would work, but the one that I outlined here is definitely the easiest. So if I plug 0 in for x, I end up getting y equals 0, and if x equals 5, we get y equals 25, and if x equals negative 2, I get y equals positive 4. This gives you the 3 critical points. 0, 0, 5, 25, and negative 2, 4 are your critical points. Okay, we need to decide now if they are relative max, relative min, or saddle points, right? And so we're going to do that by constructing your d-test formula, your d of xy formula. So go back up if you need to and construct your d formula, which is going to be made up of, let's underline these for you. I'm going to take this output times this output, and that's going to look like 12x plus 40 minus 4y all times 2, then minus the mixed partial squared. So minus negative 4x squared. And we'll simplify this a little bit. We end up getting, running out of space here. Here we go. I end up getting 24x plus 80 minus 8y minus 16x squared. All right, great. Next, I need to substitute the values of a critical point into that result for x and y. Let's start with 0, 0. So I want to find what d of 0, 0 looks like. D of 0, 0 means plug 0 in for x and y. You end up getting just 80. Now that's positive, right? So that means I have to check out fxx, the second partial, with respect to x at 0, 0. And in case you lost it, it's right up here. Okay, so plug 0 and 0, 0 in for x and 0 in for y, and you end up getting 40. Now that's positive. So what this tells you is that the point 0, 0 is a relative minimum. Do the same thing with the other two critical points, d of 5, 25 and d of negative 2, 4. So I'll work on that and you can do it simultaneously and we'll see what we all get. So I substituted the values for the critical points into the d test function. I end up getting negative results each time. I don't have to find fxx therefore, because if your d output is negative, you automatically can stop, and you now refer to that critical point as a saddle point. All right, here's our next function, c of xy. C of xy, I am going to pause the video, have you guys finish this on your own, finding the critical point or points and determining if they're relative max min or saddle points, and then the next video will show you the solution so you can check your work.